All right, what's up? Good morning. Good morning, YouTube. So we are continuing the Khan Academy SAT problems. Today we are doing isolating quantities. And not exactly sure what that means, as I haven't seen these problems yet, or this section yet. So let's just jump into it and see what it's all about. And we will solve 5 as per usual. Let's jump into a screen share. Remember, I forgot to do this last time. Here we go. And again, Instagram people, jump to my YouTube channel if you actually want to see the problems and see the screen share. And I think it'll be more fun if we do it like that. Okay, let's take this problem and let's throw it up on the whiteboard here. I didn't even get to take a look at it. So let's see what it is all about. Here we go. Okay. I see what we're doing. It's just isolation, variable isolation. So variable isolation, one of the most important concepts in math and SAT stuff. Definitely want to get. And thank you, Princess Leia, for the comment. Appreciate it. Glad you're being entertained right now. So, anyways. The variable isolation, this is at the heart of algebra. You've gotta get familiar with this concept. So let's go through it step by step. So we got A equals, it gives us this whole thing. Honestly, I can already tell we don't need to read all this, but it says this is the surface area of a cylinder with these different things, a radius and a height. And then it says which equation shows the cylinder's height in terms of its radius and surface area. What are we trying to do? We're trying to isolate H. That's all it is. So let's put up everything here. We got A equals 2 pi r squared plus 2 pi r h. And now let's isolate H. And we got H all the way over here. So first let's subtract this guy, 2 pi r squared. We can just subtract that entire term, because if we subtract that entire term, it's gone. And we do the same to this side. And by the way, guys, again, I see a few people on the Instagram feed. Go to YouTube if you want to see the actual problems and search for Scalar Learning, and you can see the YouTube live stream right now and watch me solve the problems. And we got A minus 2 pi r squared equals 2 pi r h. Now what do we have to do? We just got to get rid of this 2 pi r out of that h. Now what we got to do is divide both sides by 2 pi r, because that 2 pi r is almost like one giant coefficient. So we just divide by the coefficient on both sides. This goes away. And this is our answer. You can't really simplify it any further than this. Now, I'm looking right here, and I take that back. It looks like they did simplify it a little further. They broke this into 2 terms. So we can't, as it stands, cross anything off and simplify it that way, but we can break it into 2 terms, so we're going to have to do that to get our answer. And how can I tell that they did that in the answer choices? Everything here has 2 terms, and the answer is A, B, C, and D. So how do we split this up into 2 terms? It's a subtraction problem on top. So it's like we replicate the denominator, because technically these are 2 separate quantities over the same denominator, A 2 pi r minus 2 pi r squared over 2 pi r. You see how the denominator kind of just splits up like that? And then we can do something really special here. Now we can cross off from the top and the bottom. So we got a 2 on top and bottom, those go away. We got a pi, those go away. And we got an r and an r squared. This goes away, and this drops to a 1 exponent. Because r squared over r, we just subtract down the exponents, just becomes r. So now we have A over 2 pi r minus r. And here's our final answer, which is here, which is B. And you see that? So look, this is a really good rule. Let me throw this in the answers, make sure we're right. This is a really good rule when you're trying to when you don't see your answer choice up there. It just means that you're probably going to have to do some sort of additional manipulation. A lot of times it can be simplification like that. Sometimes it might actually be the opposite. It might actually be, instead of factoring, you're going to now FOIL and multiply out for whatever reason. They just want to know your versatility as far as manipulating these different expressions and equations. All right. Oh, this is an area of a trapezoid formula. The area of a trapezoid that has height h and bases b1 and b2 can be found by using the equation above. So there's the area of a trapezoid. Which of the following correctly shows the trapezoid's height in terms of its area and 2 bases? We're just going to isolate h. That's all this is, isolating h. And this one's really actually can be done in one step, but I'm going to break it up into two. We have 1/2 times B1 plus B2 times H. First thing I'm going to do is I'm going to actually get rid of this 1/2. And I'm going to do that by multiplying the entire equation by 2, by its reciprocal, because it's 2 over 1. Okay. That will knock off this 1/2 over here. And that will give me on the left side 2A equals B1 plus B2 times H. Okay. Now we have an entire term multiplying this H. To get rid of it, we just do the opposite. We divide both sides by B1 plus B2. Divide both sides by B1 plus B2. This goes away. Here's our answer. Let's see if we have it. Yeah, it's the last one. It's D. Okay, so that's it. We just isolated, solved for H. And what did I say it was D? Let's see. Yeah, that's correct. Hey, what's up? And Instagram guys, jump on my YouTube channel. Again, go to YouTube, search for Scalar Learning. You can see the live stream. Watch me in action. Got to figure out a way to get Instagram people to also be able to watch this. But right now I figure you can at least watch me talk about math. So, I don't know. Hopefully that's worth something that you could come on YouTube if you want to see more. All right, let's go to this one. 2d sine theta equals, I think that's lambda. I'm not sure. Molecules in many solids are arranged in a crystal lattice. All right, like I've seen this over and over on the SAT. What do? They throw out a lot of these technical terms. Crystal lattice. You don't have to know what a lattice is. With all these descriptions and details, it can be a bit confounding because, and I think that is, I do think that is part of the intention, is to almost distract you. To sort of mimic a real life scenario or problem, but it is there. So don't let that throw you. So let's just keep reading. These layers reflect and scatter light according to Braggs' law, Braggs' equation. Honestly, we could have done without that entire first two sentences. Bragg's law, excuse me. The Bragg equation relates to the distance d, so d is distance, between layers of blah, 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 which is the following correct equation for the distance. All we're doing, isolating distance. That's it. There's like 5 lines of text, and all you need to know is you need to isolate D. That's it, right? Super basic problem masked in all this crazy jargon. So we've got this lambda's already here by itself. That's cool. It's one thing. This is literally one step. We just divide both sides. Everything is being multiplied as one term, so we just divide by everything. Okay, divide by everything else. So we've got the D. We want to leave the D, so we divide by 2, and we divide by sine of theta by both sides. We divide 2 sine of theta. This goes away, and this 2 goes away. This is our answer. That's it. It's just lambda over 2 sine theta, which is A, it looks like. Okay. Let's see if we are correct. Yeah. Boom. Okay, let's go on to number 4. Let's check this guy out. And I see comment, Princess Leia. She says, actually fun or cool to visualize what I'm talking about, I guess, without seeing the live feed. That's cool. I'm glad you enjoy it. I mean, I'm trying to actually say the problem so you have a chance to write it down if need be. You probably can follow along. And if you like that, that's cool. Okay. Ka times, what is that? Chain, it's like delta T over L. The rate of heat transfer, H, of a material can be expressed in terms of its thermal conductivity, Ka. Again, a lot of jargon. I am going to skip this big chunk where it explains all this stuff because I bet you all it's going to ask is like to isolate K. That's it. So all I'm going to do is try and isolate. Okay, which of the following correctly expresses the thermal conductivity of what are you doing? North Lacey's asking. I'm solving SAT problems from Khan Academy. And if you want to actually see the problems, you just got to go to my YouTube channel, go to YouTube, search for Scalar Learning, and you can actually see the problems if you want to follow along and try and solve these along with me. All right, so it says, which of the following correctly expresses the thermal conductivity of a material in terms of its thickness change in temperature, and its rate of heat transfer. So we need to figure what's the variable that represents thermal conductivity. And well, look, actually, we can already tell. See, this is another little shortcut. We can actually tell all these answers, they're just isolating Ka. That's it. So all this, again, 5 lines of text, we don't need it. Just isolate Ka, and we're good to go. So if we have, I'm going to set it up here, Ka delta T over L. Okay. First, I'm going to multiply both sides by L because L is being divided on the right side. So the opposite of that is we multiply both sides of the equation by L. This becomes HL, these guys go away, equals Ka, yikes, this looks really bad, dt, delta T. And then we divide both sides by this thing. Delta, this is usually change in temperature. Yeah, that's what it says, change in temperature. That's what that triangle sign usually indicates. This goes away, and we've isolated it. It's HL over change in T, which is B. See that? You cut through the jargon. You cut through, what did I say, B? You cut through all that craziness and these problems. It's like that mask of complexity or difficulty. It sort of fades away, right? Like once you can break, if you get really wrapped up in that complex text and all that scientific jargon, it can be seem really overwhelming. And again, this last problem is the same type of thing. By the way, I think a lot of these problems that we've been doing have been no calculator, but that's perfect because a calculator wouldn't even help you on these problems. So it's almost better that yes, delta is used in chemistry. It is actually the triangle, because I'm just responding to Princess Leia. So she said I thought the triangle symbol delta was used in chemistry. It absolutely is. I'm using chemistry and math, but in chemistry that's always representing change. So we have a lot of changes happening in chemistry. Okay, an English teacher uses the equation above to give the composite score C on a final exam, given M correct multiple choice answers and F points on free response. This is just an equation to get a test. And look, I can already tell you what they did too. They used these crazy coefficients, 1.2272, and in front of the F, 3.0556. And I can tell you, again, I think that is just an attempt to cloud this problem up and make it seem way more difficult than it is. If these were simple numbers, it would be really easy, it would appear to be a much easier problem. But that don't let that throw you either. So which of the following correctly gives the number of correct multiple choice answers? Okay, so we're isolating for M. In terms of the composite score and everything, whatever. They were isolating M. They said, which one of the following equations gives the number of correct multiple choice answers in terms of blah, blah, blah. And in all the answer choices, M is being isolated. That's it. No questions. Okay, there's no ambiguity in what they're asking. So let's go ahead and isolate 1.2272 M plus 3.0556 F. First, I'm going to subtract this entire term on the right, 3.0556 F. 3.0556 F. Goodbye. So we got C minus 3.0556 F equals, oh God, these numbers are horrible, 272 M. And then we just got to divide both sides by this value in front of the M to isolate the M. Divide both sides by 1.2272, 1.2272. This is our answer right here. C minus 3.0556 F over 1.2272, which I think is our, let's see, what answer? A. It's A. It's right there. All right, let's go ahead and enter it, make sure we're right. Always got to make sure we're right. I don't know, could make mistakes. I have made mistakes here and there on these as well in the past. You never know. But no matter how much practice you get, you can never be totally perfect. Okay, that's it. Let me turn off my screen share. All right. So anyways, hope that was helpful, guys. We're making our way through these SAT Khan Academy problems. I think we're about halfway or a little more than halfway. So hopefully this is helpful and useful. And I got a quick announcement too. I'm working on my next music video, which is all about special right triangles, and that should be done by next week. We'll see what happens. I'm shooting for Monday. Don't know if I'll pull it off, but it's definitely gonna be done next week. I can't wait to release it. I think it came out really well, the song anyways, and the video's in the works. So make sure to check that out. Instagram, thank you so much for joining. I hope that was helpful, useful, beneficial. And YouTube, as always, thank you guys. And see you next week on Monday. Peace.